Hey guys, welcome to the unit digit topic. My name is Saravana and this video is produced by 6 Phrase the Finishing School. And these are some of the videos that you can expect from us in the future. Okay, let's get into the topic. Unit digit. What is unit digit? Uh, for example, in this number, which digit would you say is the unit digit? So, in this number, 5 is the unit digit. Let me give you another number. In this number, what is the unit digit? 8 is the unit digit. Okay. Another number. What is the unit digit? 6 is the unit digit. Now, if you take digits from 0 to 9, which is called decimal system digits, you will find different unit digits for different numbers. Okay. So, we are going to look at what the unit digit is for specific digits. And some I want to give you a kind of feel of how questions will be under unit digits. Okay, for example, they'll ask you what is the unit digit of 8 power 97, or what is the unit digit of 3 power 49, what is the unit digit of 7 power 29, what is the unit digit of 2 power 42, or what is the unit digit of 9 power 87, what is the unit digit of 4 power 102, what is the unit digit of 6 power 15. Now, as you can see, you can all these questions, in all these questions, you were finding the unit digits of 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, these 10 decimal system digits. So, in all these questions, you were asked to find the unit digits of powers of these digits. Okay, so we'll see how to do it. So, we'll take one digit at a time and then we'll take this forward. Now, let's take the digit 2. Okay, for this we say the cyclicity of digit 2 is 4. Okay, the cyclicity of digit 2 is 4. Tell you what the reason is. 2 power 1, what is the unit digit? 2. 2 square, it is 4. 2 cube, it is 8. 2 power 4, it is 6. 2 power 5, it is 2. 2 power 6, it is 4. 2 power 7, it is 8. 2 power 8, it is 6. Again 2 power 9, it is 2. 2 power 10, the unit digit is 4. 2 power 11, the unit digit is 8. 2 power 12, the unit digit is 6. Okay. Now you can see for 2 power 1, 2 power 5, 2 power 9, what is the unit digit? It is 2, right? For 2 square, 2 power 6, 2 power 10, what is the unit digit? It is 4. For 2 cube, 2 power 7 and 2 power 11, what is the unit digit? It is 8. For 2 power 4, 2 power 8 and 2 power 12, what is the unit digit, guys? It is 6. So you can see there is a pattern. So what is the pattern? That is what we are going to take a closer look at. Okay. Now for 1, 5, 9, 13, 17 and you go on like that. Divide it by 4. What is the remainder that you get? It is 1. Okay. So you can see this 1, 5, 9, 13 are nothing but powers of these expressions 1, 5, 9. Okay. So when the remainder is 1, you divide all these numbers by 4, you get a remainder of 1. When the remainder is 1, yeah, that is the unit digit. Okay. Now we look at another set of numbers. 2, 6, 10, 14, 18 and divided by 4. Okay. What are these numbers? These are the powers of these sets of numbers 2, 6, 10. Okay. Now you divide this, you get remainder 2. If remainder is 2, then 4 is the unit digit. Okay. The next set of numbers 3, 7, 11, 15, 19 divided by 4, you will get a remainder of 3. If the remainder is 3, yeah, 8 is the unit digit. 4, 8, 12, 16, 20 and so on divided by 4, you get a remainder of 0. If the remainder is 0, 6 is the unit digit. Okay. Now we'll take a couple of problems. Let us say they've asked you to find 2 per 35. Okay. Now look at the power. Okay. What will you do? You will have to divide this power by 4. So that is what we've been doing here, right? So divide this power by 4. So divide 35 by 4. What do you get? You get remainder of 3. So when the remainder is 3, yeah, 8 is the answer. Okay. Next one, 2 per 49. Okay. Again, divide 49 by 4. What is the remainder that you get? Remainder is 1. The remainder is 1. 2 is your answer. Okay. So did you get it? Pretty simple, right? Now let's look at digit 3. Okay. For digit 3, we say the cyclicity is 4, meaning it is very similar to 2 in that sense. Okay, so we'll see why we say the cyclicity is 4. Okay, 3 power 1, the unit digit is 3. 3 square, the unit digit is 9. 3 cube, the unit digit is 7. 3 power 4, the unit digit is 1. 3 power 5, the unit digit is 3. 3 power 6, the unit digit is 9. 3 power 7, it is 7. 3 power 8, it is 1. 3 power 9, it is 3. 3 power 10, it is 9. 3 power 11, it is 7. 3 power 12, it is 1. Okay. Now guys, take 3 power 1, 3 power 5, 3 power 9. What is the unit digits for all these terms? 3, right? Take 3 square, 3 power 6, 3 power 10. What is the unit digit for all these terms? It is 9. So take 3 cube, 3 power 7, 3 power 11. What is the unit digit for all these terms? It is 7. 3 power 4, 3 power 8, 3 power 12. What is the unit digit for all these expressions? It is 1. Okay. So you can see you have 3971, 3971 repeating. Okay. So you saw that here, right? 3971 was repeating. So that is why we say, because we have 4 numbers, 1, 2, 3, 4, we say the cyclicity is 4. Okay. And that is the exact reason why we divide the power numbers by 4. Okay, this is the exact reason. Okay, so 1, 5, 9, 13, 17 divided by 4, you know what those numbers are. Yes, you get the remainder of 1. So the unit digit is 3 for all these numbers. 2, 6, 10, 14, 18 divided by 4, you get a remainder of 2, and 9 is the unit digit if you get the remainder 2. 3, 7, 11, 15, 19 divided by 4, you get a remainder of 3, and 7 is the unit digit if you get the remainder to be 3. 4, 8, 12, 16, 20 and so on and so forth divided by 4, you get a remainder of 0, and 1 is the unit digit and you get a remainder to be 0. So we look at a couple of problems. 3 power 35. So what do you do? Take 35 divided by 4. Okay, you will get a remainder of 3. So when you get a remainder of 3, yeah, 7 is your unit digit. 3 power 89. Sorry, yeah, 89. Yeah, divided by 4. What is the remainder that you get? It is 1, right? So when you get a remainder of 1, 3 is your unit digit. Pretty simple, right? Yes, very simple problems. Now for 4, the cyclicity is 2. Okay, we'll see why it is 2. Okay, for 4 power 1, the unit digit is 4. For 4 square, the unit digit is 6. For 4 cube, the unit digit is again 4. For 4 power 4, the unit digit is 6. For 4 power 5, the unit digit is 4. For 4 power 6, the unit digit is 6. So you can see for 4 power 1, 4 cube, 4 power 5. For all these expressions, the unit digit is 4. 4 square, 4 power 4, 4 power 6. For all these expressions, the unit digit is 6. Okay. So because we have 4 and 6 alternating, and because we have two possible unit digits, we call cyclicity to be 2. Okay. For the digit 4, the cyclicity is 2. So it is very easy once you know that you have the cyclicity is 2, because see, 1, 3, 5, 7, these are the powers of these terms. Okay, you divide all these number by 2. Okay, so what do you get? You get a remainder of 1. Okay, or in other words, shall I say all these numbers are odd numbers? Yes, yes, they are odd numbers. Okay, so if the remainder is 1, then yeah, that is the unit digit. Okay, for 2, 4, 6, 8, 10 divided by 2, remember you have to divide it by the cyclicity number. Okay, previously it was 4, now it is 2. Okay, now divided by 2, you get remainder of 0. Okay, so when the remainder is 0, we also call these numbers even numbers, and that is the 6 is the unit digit. So for odd numbers of powers of 4, we get 4 as the unit digit. For even numbers of powers of 4, we get 6 as the unit digit. So you just have to look at the power, see if it is odd or even. If it is odd, 4 is the unit digit. If it is even, 6 is the unit digit. Okay. What is 4 power 35? Is 35 odd or even? Odd. Okay. So if it is odd, 4 is our unit digit. What is 4 power 88? 88 odd or even? Even. Okay. So if it is even, 6 is your answer. Very simple. Now for 7 and 8, okay, we have to look at powers of 2 again. Okay, so we'll see what, I'll tell you why it is so. For 7 and 8, the cyclicity is 4, which is same as 2 and 3. For 2 and 3, you saw that cyclicity is 4, right? So for 7 and 8, cyclicity is again 4. Okay, so we'll see the powers of 2 have 2, 4, 8, 6 as their unit digits. You know that, right? Yes. Now, powers of 8 will have 8, 4, 2, 6 as unit digits. Okay. Now, I want you to understand how this happened. Okay. Now, the two numbers of interest to us, something's blinking there, right? Yes, it's 2. Okay. And it is 8. Okay. Now, take those numbers. What happened is 8 came here. Okay. Then 2 came there. Okay. So that is how it became 8426. Okay. So 3971 are the unit digits of 3971 are the unit digits of 3. So powers of 7 will have 7931 as their unit digits. Okay. Now, so you can see it is 3971. Here it is 7931. Okay. Here it is 8426. Okay. For 9. Okay. 9, guys, is similar to 4 in that the cyclicity of 9 is 2. Okay. And the cyclicity of 4, as you saw, was also 2. Okay. So 9 power 1 is 9. 9 square is 81. 9 cube is 9. 9 power 4 ends in 9. 9 power 5 ends in 9. 9 power 6 ends in 1. Okay. So for 9 power 1, 9 power 3 and 9 power 5, the unit digit is 9. For 9 square, 9 power 4 and 9 power 6, we'll see what the unit digits are. So for the first category, the unit digit is 9. For the second category, the unit digit is 1. Okay. So for 1, 3, 5, 7 and 9, if the powers are 1, 3, 5, 7 and 9, divided by 2, because the cyclicity is 2, so divided by 2, you will see that they are odd numbers. If it is odd, 9 is the unit digit. Okay, 2, 4, 6, 8, 10 divided by 2. Okay, 2, 4, 6, 8, 10 are the powers of these expressions. Okay, now they are even numbers, and if it is even numbers, 1 is your unit digit. Okay, so 9 power 44. 44, guys, is it even or odd? It is even. Okay, so 1 is your unit digit. 9 power 1025, is it even or odd? It is odd, so 9 is your unit digit. Okay, so that is a summation of what we've seen. Okay, we saw 2, 3, 4, 7, 8, and 9. 4 had cyclicity of 2, 9 had the cyclicity of 2. 2 and 7 we interchanged things for, sorry, not for, it's for 2 and 8 we interchanged 2 digits, right? So for that we have this yellow colored mark, and 3 and 7 we get it by interchanging. Okay, so 3 and 7, you interchange these two numbers, you'll get 7. Interchange these two numbers, you'll get 8. Okay, and for 0, 1, 5 and 6, those things that are marked in white color, okay, all those things have cyclicity of 1, which means 0 par anything ends in 0, 1 par anything ends in 1, 5 par anything ends in 5, and 6 par anything ends in 6. So we'll look at some problems. Unit digit of a big number. So this is a very large number. Okay, don't get confused or don't get overwhelmed with anxiety looking at the numbers. Now what you do is, this is the given number. Okay, now this part which is in black we are not worried about. Okay, so this part we are not worried about. Okay, the unit digit of this part gives you the unit digit of this whole question. Okay, what is the unit digit of this part? It is 5 par something. Guys, you know 5 par anything, what is the unit digit? It is 5, right? So the answer for this question is 5. It is as simple as that. Again, unit digit of, again, a very large number. Again, when you have a large number, don't panic. What you do is, take this away. We don't need this. So the unit digit of this part will give you the unit digit of this whole question. Okay, now guys, this digit is 4. This has a cyclicity of 2. Okay, in the cyclicity of 2, look at the power. Is it even or odd? It is odd. When the power is odd, then the answer is 4. Okay, had it been even, your answer would have been 6. Unit digit of 1 power 1 plus 2 square plus 3 cube plus 4 power 4 plus 5 power 5 plus 6 power 6. Okay. Now 1 power 1, what is the unit digit? 1, right? 2 square, what is the unit digit? You know it is 4 because 2, 4, 8, 6 is the cyclicity. 3 cube, you know it is 7 because 3, 9, 7, 1 is the unit digit cycles. 4 power 4, okay. You know even powers of 4 ends in 6. 5 power 5 is 5. 6 power 6, all powers of 6 ends in 6. So finally you add them up, you get 29, and the unit digit of our answer is 9. Okay. Find the last digit of 2001, 2 power 1999 into 2002, 2 power 2003. Okay. Now 1999 divided by 4, what is the remainder? The remainder is 3, guys. If the remainder is 3 for the digit of 2, you know 8 is the unit digit. Again 2003 divided by 4, what do you get? Remainder is 3. For the digit of 3, for the digit of 2, if the remainder is 3, 8 is the unit digit. So 8 into 8 is 64. So our answer is 4. Unit digit of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial and so on and so forth. Okay. This question might seem very difficult at that first look, but it is not so. We'll see how it is very easy. Now, tell me the unit digit of 1 factorial. Okay. You know it is 1. 2 factorial, guys, it is 2, you know that. 3 factorial, it is 6. 4 factorial, it is 4. Now for 5 factorial, the unit digit is 0. For 6 factorial, Also it is 0. For 7 factorial, again it will be 0. For 8 factorial, it will be 0. So if you look at the unit digits, you are going to just do the sum of 1, 2, 6, 4, 0, 0, sum of all this and a host of zeros. Finally, you will end up with 13 and the final answer is 3. See how simple it is? The unit digit of 1 factorial per 99 plus 2 factorial per 98 plus 3 factorial per 97 plus 4 factorial per 96 up until 99 factorial per 1. Okay. So 1 factorial per 99. Well, guys, what could be the unit digit for this? It is 1. 2 factorial per 98 is nothing but 2 per 98, right? So the now 98 divided by 4, you divide 98 by 4, you get the remainder to be 2. If the remainder is 2, the unit digit is 4. You know that, right? For 3 factorial, it is 6 per 97. So 6 per anything is always 6. For 4 factorial, you get 24 per 96. So you are interested in only 4 per 96. 4 to the power of even number will give you what? It will give you 6 as the unit digit. 5 per factorial by 9, which is 120 to the power 95. Now the unit digit of this expression nothing but unit digit of 0 per 95. Okay, so what is the unit digit of 0 per 95? It is 0. Okay, so then the 6 factorial again it will be 0. For 7 factorial it will be 0. For 8 factorial 9 up to 99 factorial, for all these values the unit digit will be 0. Okay, so you just have to do the sum of 1, 4, 6, 6, 0, 0, 0 and a whole lot of zeros, and it is very simple. It is 17 and finally you will get your answer to be 7. Okay, what is the unit digit in 7 per 95 minus 7 per 3 per 58? Okay, now I am going to give you 4 options, guys. Take a moment, okay, pause this video and work it out and have an answer ready. Okay, only then proceed with the explanation that I am going to give you. Now pause the video now. Okay, I hope you've done the calculations and are ready with your final answer. We'll see if what you got is correct or wrong. Okay, 7 per 95 minus 3 per 58 gives you, now take the power. Okay, because it is 7, the cyclicity is 4, so you divide it by 4, you get a remainder of 3. So here it is, the power is 58, so take that 58 divided by 4, because for 3 the cyclicity is again 4. Okay, so you get a remainder of 2. Okay, well, you know, when the remainder is 3, for the digit of 7, when the remainder is 3, what is the unit digit? It is 3, right? For the remainder of 2, when the digit is 3, what is the unit digit? For a remainder of 2, when the digit is 3, what is the unit digit? Okay, so this gives you so the unit digit here will give you 3 and 9. Okay, because this and this are the same things. Okay, so this becomes 7 per 95 becomes 7 is the same as 7 cube. 3 per 58 is the same as 3 square. Okay, so for 3 square the unit digit is 9. For 7 cube the unit digit is 3. So you will end up with 3 minus 9. Okay, so 3 minus 9. So does it mean we get an answer of minus 6? In other words, 6 as the remainder. Is it true? Can we do it like that? Of course, it is not possible. I told you, guys. See, when you are trying to do unit digits, your unit digit cannot be negative. Okay, so and when you subtract 3 minus 9, this is where people make mistakes. So you make sure you are alert, you are listening and understanding this. Okay, don't subtract 3 minus 9. What is the usual way in which you subtract? 3 minus 9. You take a carry, yes. Instead of 3 minus 9, you do 13 minus 9. Yeah, yes. So finally, you'll get 4 as the answer. So that will be the unit digit. Okay. So when you're subtracting, guys, make sure you are doing it this way. Okay. So anyway, so that's about it, guys. So until I meet you in the next video, that is bye. Hey guys, welcome to the last video in the numbers topic. As you can see, it is a BODMAS rule. I am very sure that you've heard this term BODMAS, but let us see what it really means. BODMAS. What does BODMAS really mean? BODMAS. A few of you already might have an idea of what BODMAS is and why we write it in this order. Okay, so there is a specific reason why we write it in this order. It is because you have to perform operations in this order from top to bottom. So first we should do B, then O, then D, then M, then A, then S. Okay. So we'll see what those letters actually mean. So B represents brackets. So there are 3 types of brackets. So we'll see all those things. This is this and this. Okay, this is a very ugly drawing of the brackets. You will see a more perfect drawing in the next slide. Okay, now off. Now what does off mean? Again, we'll talk about off in detail. Off or order of. D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction, right? So so now I give you a question. Okay, now the question is, you have 55 plus 4 or 11. Okay, now 11 minus 55 into 4. Now which will happen first, guys? You do 55 plus 4 first, or 55 11 minus 55 first. According to this, addition happens first, so you will do this first, right? Yes. See, in a way this is correct, but it is also wrong. I'll tell you what it means. Let me give you one more example for this. Now 4 into 3 divided by 1. Okay, guys, in this example, what should happen first? Okay, so you say according to this rule, division must happen first, right? Yes. Now this is the usual way people teach you BODMAS rule. Okay, they say brackets. This is, so I'll also give you the order. This should happen first, this should happen second, third, 4, 5, 6. Okay, but I'm here to tell you this is totally and completely wrong. Yes, you heard me right. This is totally and completely wrong. Okay, so we'll get to the exact how the original rule was. It was not even BODMAS. BODMAS was a term coined by the Indian people. This is actually what I call as the order of order in which you do operations. Okay, so our order of precedence of operators is what we should call this. Okay, so BODMAS is because in some places it is called PEDMAS. Okay, so you'll see that, but more in US it was PEDMAS. P stood for parenthesis, E stood for exponents. So BODMAS is a term coined by Indians. Okay, now so it depends different from place to place. So if you clearly understand the root from which all these different types, BODMAS, PEDMAS, all these things came about, then you'll have a clear understanding of what to do, and you'll do it without any mistake. So we'll see the original, the real, the first form of operator precedence. Okay. Now see, this is what it is really called, order of operations. Now the first one is brackets. Okay, so I agree with them. Brackets. See, why would you use a bracket? Okay, tell me why you use a bracket. If you have 4 plus 5 plus 7, now you use a bracket to say or group all these three terms together. Yes, to group all these three terms together. So that is the use of a bracket, be it this bracket or this bracket or this bracket. Okay, or there is a line, sometimes there will be a line like this. Have you seen it? Okay, this means this was also used to group stuff. This line is what is called as vinculum. Okay, even now you see it in some of the decimal digits where it is used like this, 25.37. Now what does this mean? This vinculum represents that 37 keeps on repeating. Okay, this is 37, 37, 37, and it goes on like this. Okay, that is the this. So basically this is used to group things. Okay, that is how you should understand it. Now you always start from the inner brackets. Let us say you have three brackets. Obviously they won't be at the same place. One will be inside, one will be in the middle, or the other will be outside. So you always start from the inner brackets. Okay, now vinculum, a horizontal line. Okay, so they are talking about the vinculum. So I told you, right, vinculum is a horizontal line. It was used to group stuff, but right now vinculum is almost it is totally replaced by parenthesis. Nobody uses vinculum anymore. So that is why vinculum, but you just, in case you encounter any vinculum symbol, you have to know it is the same as parenthesis. Okay, so vinculum is usually used to group things, is completely replaced by parenthesis. These days vinculum finds its usage in representing repeating digits after decimal like this. Okay, so guys, you can see all these digits and also the order in which it should be executed. For example, if you had a vinculum and a circular bracket, first go for the vinculum, solve it first, give the precedence to vinculum. Okay, then go solve circular brackets, then go solve curly brackets, then finally solve square brackets. Okay, so if just circular brackets are given, what do? You start from inner and go to outer. Okay, if just any one kind of brackets are given, but there are multiple brackets, you start from inner and go outer. Okay, now we look at this very misunderstood second O term. Okay, now some people say order, some people say off. Okay, now what would I say? I would say it is both order and off. Okay, you'll understand what I mean. It is both order and off. The reason is, guys, pretty simple. Okay, I'll tell you why. First we'll see why it is called off, then we go to order. Okay, now why it is called off? Let us take an example. When people say 3 of 5, okay, what does 3 of 5 mean? Just think about it. What does 3 of 5 mean? 3 of 5 means there are 3 5s. Okay, there are 3 5s. Okay, so that is what you have, 3 5s. So what do you do with this 3 5s? 3 5s, you have 3 5s. So if you'll get 5 cube. Okay, that is 3 of 5 means. So 3 of 5 means 3 5s. So you guys, you have 3 5s. Here you have 5 cube. Okay, so this is actually off here represents multiplication, right? Yes, 3 of 5 means off here you have 5 3s. Okay, 7 of 5 means you have 7 5s. Okay, so this is where this off operator comes in. So people usually say off or people usually link or relate off with this symbol, multiplication symbol. The reason is because of this. 3 of 5 means this. Then one more thing, I'll also tell you why off is related to multiplication. Okay. Now you guys know if 5 cube is called exponents because this is an exponent. Okay. Now look at this, 3% of 100. Now 3% of 100, what do? 3% is nothing but 3 by 100. Yes, of, so you have a multiplication symbol 100, you put that 100 here, right? So of is always related to multiplication, and is because of this reason. Okay, so if you ever come across any question which says of, just replace that of with multiplication sign. Okay, it is as simple as that, then you get the answer. Now, so we are done with this off. What is this order? Okay, so we have to worry about this order. Okay, now this order, by order, what they're trying to say is you have to worry about, see, whenever you have a multiplication symbol, there is a high probability that you will be having powers. Yes, so you solve it first. Okay, when you have off, solve it first. When you have powers like this, okay, you solve it first. Okay, after brackets you give importance to these things. Okay, after brackets give importance to off here, after brackets give importance to power, and after brackets give importance to this something called radicals. Okay, now we are going to look at what are radicals. Okay guys, when I say, I want you to answer this, when I do this, you will say the answer is 2, right? You'll give me the answer to be 2. Okay guys, now what do you call this symbol? Okay, this symbol is called by what name? Can you tell me? Most of them will say it is square root symbol. Okay, that is the biggest mistake that you can do. Okay, it is not square root symbol. See, this is square root symbol, this is cube root symbol, this is fourth root symbol. Okay, that I agree, but here do you have a number here? No, right? So we don't know what root this is. Okay, but it is taken as a standard that if you don't have anything, it is square root. If you have something, then it is cube root or fourth root or fifth root or something like that. So, but actually, to be very specific, this sign is called radical. Okay, this sign is, if I have to like use the perfect term that is used in mathematical, this term is called radical. Okay, if I have to use a perfect term that is used in mathematical circles, it is radical. Okay, now this doesn't mean square root, this doesn't mean cube root, this doesn't mean to the root to the power, I mean fourth root. Okay, this means square root, this symbol means cube root, this symbol means fourth root. Okay, because a number is written there. If there is no number, it is called radical. So when I say radical, I am referring in general to all these second root, third root, fourth root, fifth root. So when it comes to order of, you might encounter off. So solve this. Powers if you have solved this, radicals if you have solved this. These three things you have to solve in this precedence, in the second precedence. After brackets, this is where you have to give importance to. If you don't have any of this, then move on to the next one. Okay. So these are called radicals. So values of these steps come under this category. Okay. So next we go to division and multiplication, guys. Both division and multiplication. What if division and multiplication appear simultaneously in an equation? Now what do? You go to, see, when I say 3, division, multiplication, both have the same precedence. So this is why I said in BODMAS, if we go back, previous slide, we'll go back. So take some time, but still we'll go back. This will say sometime. Yes, in this slide, guys, see, here it says division has a precedence of 3, multiplication has a precedence of 4. This is wrong. Okay, both have precedence of 3. Okay, similarly, this says addition has a precedence of 5, subtraction has a precedence of 6. This is also wrong. Okay, Both have a precedence of 4. Okay. Now, then how do you differentiate between addition and subtraction? What do you do when they both appear? Okay, if they don't appear in the same equation or expression, you don't have a problem. But if they both appear in the same expression, which do you give preference to? Do you prefer addition first or do you prefer subtraction first? If both division and multiplication come in the same expression, do you prefer division first or do you prefer multiplication first? We'll see what to do in that situation. Yes, we are here, right? Yes. Now, what if you are put up in this situation, in a tricky situation? Now, it is, guys, it is easy. If any of you done some coding, you'll know the answer for this. You start from left and do go right. Okay, so you don't worry about division. What is first? Okay, division can be first, multiplication can be first. Okay, you don't worry about that. You start from the left and go right. Okay, uh, we'll move on to the fourth precedence. Guys, it is addition and subtraction. Again, if the same problem appears, both addition and subtraction appear simultaneously, what do? You don't have to do what this guy does. Okay, you just have to start from left and end on the right of the expression. Okay, it is as simple as that. Okay, and it is my responsibility to tell you what is starting from the left and ending on the right mean. Okay, so you might ask this question that this bunny is asking. Okay, is it a bunny? I'm not sure. Okay, uh, now, so you start left and end on the right of the expression. What does it mean? Okay, so I'll tell you what it means. Guys, this is the expression, and yeah, this is the expression. Now, you start left and end on the right. What it means is, first, what what is the leftmost operand? Sorry, operator. It is this, right? So the leftmost is multiplication. So first thing that you have to do is 46 into 2. So that is what is appearing up here. So 46 into 2, the thing that is shimmering. Okay, 46 into 2 is shimmering, right? That is the first thing you have to do. Okay. Now what is 46 into 2? It is 92. Okay, then you do the divide symbol and then have the 4 there. 92 divided by 4 will give you 23. Okay. Now if you do it the other way around, you might not get the correct answer, or some, see here you'll get the same answer, but in other cases when the division appears first, you won't get the correct answer. So do it from left to right always to avoid confusion, guys. If you want to get the answer all the time correctly, make sure you do it from left to right. Okay, once or twice you may get the answer if you do it both ways, left to right and right to left. So don't get confused with this is wrong, both is working. So don't think things like that. Okay, sometimes you might get it. Okay, if I have to explain that why am I getting it for some cases and not getting it for some cases, we don't have time for that. Okay, right now just understand or do your own research why we do that. But left to right, if both multiplication and division symbols appear in the same expression. Okay, so I'm going to give you one more where we are dealing with addition and subtraction. So again, if you have both addition and subtraction, start from left to right. So 46 minus 2 happens first. So what is 46 minus 2? See, it is shimmering. 46 minus 2. So you from the left, the first operator is minus. Okay, so 46 minus 2 is 44 plus 2. Sorry, plus 4 gives you 48. So it is as simple as this. This is what starting from left and end on the right means. Okay. Now giving you a pretty large expression, so we'll see if you get it correctly. So guys, to sum it up, first brackets, then go for order of brackets have vinculum, vinculum, circular brackets, curly brackets, and then square brackets. Okay, this is the order. Okay, I say it in order. Then order of, when you encounter anything which is off, remove that off and replace it with a multiplication symbol. And when you encounter something with powers, then that becomes under order of. You encounter something with radicals. Radicals is that sign that you put for root. Okay, so yeah, I talked about radicals. Okay, so what's that video carefully. I mean, watch the space carefully. Anyway, uh, to solve this expression, what we do is 46 by 2. Now first thing is brackets. Okay, solve all the brackets. So 46 by 2 became 23. 53 by 2 plus 2 became 55. 15 square is 225 minus 10 becomes 215. Root of 25 is, guys, 5. 5 minus 4 is 1. Okay. So now you can remove the brackets. So that is what I'm doing. So the brackets, no brackets, no difference. Okay. Now what is it? You have a negative sign and a multiplication sign. So which one do you do first? You do the multiplication first, right? Because multiplication comes under the third precedent. Negative sign comes under the fourth precedence, right? So you do the multiplication. So what you guys do is you do the shimmering thing. So what is shimmering? It is 55 into 215. Now guys, you get 11825. Finally you get 11802. So this is how you solve it. Okay, so we'll soon see more problems so you will understand it. Okay, but before that, the next concept in this video is prime check. Sometimes they'll ask you, they give you a number and ask you if the number is a prime number or not. So you must be able to answer it. Okay, I am going to tell you how. So watch the space carefully. So if I give you this number, can you see this number? What is the number here? 2, right? So if I ask you if this prime, your answer will be, so go ahead and give your answer. Okay, now is this prime? 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 Guys, is this prime? Is this prime? Now, for all the previous questions, you would have answered that everything is prime. Am I right? Okay. If you did not answer it, I would highly suggest you to go look up the first 5 to 10 prime numbers at least. Okay. Just look up the first 5 to 10 prime numbers. For others who answered that everything is prime number, can you surely say this is a prime number? 113. Can you say for sure 100%? Like you know 2 is a prime number, right? That is 100% sure. But can you 100% sure? Can you say for sure 100%? Okay, anyway. 1/3, can you say for sure 113 is a prime number? No, not many can do it. Okay. Again, if I ask you 139, is it a prime number? Again, not many can say for sure. 163, not many. 179, nobody can say it. I think 197, I cannot say that. I don't know if 197 is a prime number or not. Okay, I don't know about you guys. Okay. Now, then how do we find a number to be, or check if a number is prime or not? Okay, guys, for that you have to understand what is a prime number. Okay, you already know this, I guess. In the previous videos I would have mentioned what a prime number is. What is a prime number? A prime number is a number which has only 2 factors, and those 2 factors are always 1 and itself. So this is a very short but accurate definition of prime numbers. Okay, a number which has only 2 factors, 1 and itself. Now, how many factors does 197 have? That is what you have to check, right? If you find that there are only 2 factors, 1 and 197, then you can say it is a prime number. Okay, or if you find any other factor other than 1 and 197 for 197, then it means it is not a prime number. Okay, so how do you find factors or number of factors? The number of factors is 2, it is prime numbers, right? If you listen to my previous videos where I talked about prime factorization, the number of factors can be easily found if you do prime factorization. Okay, so we'll go in that route. Okay, we'll take that route. Okay, so we'll see if we can do prime factorization for 197. So what will you do? You will divide it by 2. 2, it is not divisible, right? 3, it is not divisible, surely. 5, not divisible. 7, not divisible. 11, not divisible. 13, not divisible. 17, not divisible. Guys, when I say it is not divisible, it is not divisible. Okay, you need not double check it and calculate this. Not divisible. Not divisible. Not divisible. not divisible, not divisible, not divisible, not divisible, not divisible. Now, now he is trying to ask you something. I'll tell you what he is asking you. Okay, but I have a question for you. Now, what was the last number that you saw? I guess it is 47, right? Now, by the time you end up checking if 197 is divisible by 47, you have to start from 2. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So by the time you end up checking all these numbers, I think your exam will be over. And, and it will be time for you to give the paper to your invigilator. Okay. So what is the one thing that he is trying to say is, please don't do this approach or take this route. I was talking about taking a route, right? So don't take this route. Okay. We have a much simpler way of doing things. Okay. But again, guys, the shortcut, there is a reason behind the shortcut. If I go explain, if you want, just put it in comments or give your comments. We'll make a separate video for the reason for this shortcut. Okay. So when I say do this, you do this. If you want to know why we do this, then we'll have to make a separate video for it. We don't have time right now for it. Okay. Now this is the same. We're going to take the same 197, guys. Okay, the shortcut is this. You take the square root of 197. It's something like 14 point something, because square root of 196 is 14. Okay, so 197 will be 14 point something. Now what you do is take this 14 inside this and put it here. Now now you have to look for prime numbers below 14. What are the prime numbers below 14? So 13 will come here. 11 will come here, 7 will come here, 5 will come here, 3 will come here, and 2 will come here. Okay. Now look at this 197, guys. Now right now, the previous slide you saw, I was dividing 197 by 2, 3, 5, 7 up until 47, and it did not end. We'll have to move on 47. After that we have 53. Right, next prime number after 47 is 53. So we'll have to move on like that. Okay. Now that might be very, very time. What if 197 was divisible by 91? Then till 91 you will be dividing it, and this problem would have taken you 30 minutes. Okay, where you should have solved it in 1 or 2 minutes. Okay. So here what it suggests is, you take the square root and you just need to check for these numbers alone. Okay, you just have to check for these numbers alone, and this number also, if this number was a prime number. Okay, if you look at it, all these are prime numbers. I've taken only prime numbers less than 14. Okay, so this is prime less than 14. That is what we are going to check. Okay, so that will be a very limited set of numbers which you can use to divide 197 by. So first, guys, one thing is, you don't need to check if it is divisible by 2 or not at all, because just look at this. So you definitely know it is not divisible by 2. Okay, and 5 also you need not check, because if it was divisible by 5, last digit will be what? 0 or 5, right? So 2 and 5 you don't check. Okay, so I'll talk about it in the next slide. 3 is not divisible by 3, 5 not divisible, 7 not divisible, 11 not divisible, 13 also not divisible. That's it. Okay, now you can come to a conclusion, because it is not divisible by any of those things. You can say 197 is a prime number. Okay, because what it means is only 1 and 197 are factors for 197. Okay, so you, instead of checking all the numbers from 1 to 197, it is sufficient, or all the prime numbers, it is sufficient that you take the square root of 197, check the prime numbers which are below the square root. Okay, here the square root was 14, and the prime numbers below that were only used to check. Okay, and that is sufficient. Again, for the reason for this, we need a lot of time. Okay, there is a reason. So 187. Guys, 187 is 169 is 13 square, right? So 13 point something. So we put 13 down here. Okay. Now I'm going to take all the prime numbers below. Now, divisible by 3, definitely not. Divisible by 5, definitely not. Divisible by 7, no. 11, yes. Okay, it is divisible by 11. 11, what is 11? 17 into 11. What is 17 into 10, guys? 17 into 10 is 170, right? 17 into 11 is 187. So it is divisible. So what does it mean? It means 187 is not a prime number, right? Anyway, so like I told you, whenever you are asked to check if a number is prime or not, check if it is even, check if it is divisible by 5, okay? Then go to this step, okay? The first thing is you eliminate 2 and 5. Okay, 2 and 5 you can do it just by looking at the number. So that is why I am giving you those steps at the top. Then finally follow this method that I just gave you, okay? Now, harmonic progression. Guys, arithmetic progression, I know you've seen arithmetic progression, right? So let us see 1, 2, 3, 4. If I have to tell you what is harmonic, these are numbers which are in arithmetic progression. If you want to find the numbers which are in harmonic progression, you just have to do the ulta, okay, or reciprocal. What is 1 reciprocal? 1 by 1. What is 2 reciprocal? 1 by 2. 3 reciprocal is 1 by 3. 4 reciprocal is 1 by 4. 5 reciprocal is 1 by 5. So all these numbers are in AP. All these numbers are in HP. Okay, guys. So this is harmonic progression. You inverse arithmetic numbers which are in arithmetic progression, you get harmonic progression. Okay, so it is as simple as that. Now A plus D, A plus 2D, A plus 3D are in arithmetic progression. You know those numbers are in arithmetic progression because they have a common difference D. Okay, but what you don't know is, if you inverse them, you will get harmonic progression. Okay, so if A, B, C, D are in arithmetic progression and doesn't contain a 0, okay, why is it that it should not contain a 0? If you inverse 0, what will happen, guys? It is not defined. Okay, if you inverse 0, it is 1 by 0, right? Any number you divide it by 0, what do you get? You get an undefined number. Okay, people say infinity. It is not infinity. It is undefined. Okay, they don't know. Okay, undefined means they don't know what is 1 by 0. Okay, so you should not have a 0 in your arithmetic progression. So if you don't have a 0, then you can say the reciprocal 1 by A, 1 by B, 1 by C, 1 by D are in harmonic progression. Guys, see, this is the graph of harmonic progression. Okay, so let us take this number 2, 3, 4, 5, 6. Then harmonic progression is 1 by 2, 1 by 3, 1 by 4, 1 by 5, right, guys? Yes, so look at this graph. Okay, I want you to look at this graph and pay close attention to the graph. Just stop the video and pay close attention to this graph. Okay, you're going to see something amazing in the next 2 slides. Okay, you're going to be seeing some videos. Okay, but for that to sink in, you have to look at this carefully. I want you to take the shape of this graph. Okay, picture it in your mind. Take the shape of this graph, picture it in your mind. Okay, now pause it, do it. Okay, when you have time, you can come back. Okay, we'll move on to the next slide. Yes, this is something that you have to see. Okay. So have you seen this guy? Well, now you see him. Okay, now listen to him.
Hi, my name is Michael, and on this episode of Michael's Toys, we are going to be playing with blocks. I'm sure you've played with blocks before and have noticed that it's quite fun to put one block on top of another. It stays. You can keep doing this and build a tower as tall as you want. But what if you don't want the tower to just go up? What if you also want the tower to go to the side? How far can it reach over to the side without falling over? Well, this question is known as the block stacking problem, and its solution is the leaning tower of liar. You can actually mechanically build a leaning tower of liar just by feel, by taking a number of blocks. Here I've got 5. And notice that when I put one block on top of another, that top block can be pushed out, but only to a certain point, beyond which its center of gravity, the point from which gravity appears to be pulling it down, is no longer above the support, and a torque is produced and the object rotates off. So if I make sure the center of gravity is just above the support, it will stay. But now I can treat both of these blocks like a single object and balance them on top of a third block. Now, just by feel, not using math or engineering, I'm just gonna see how far out both blocks can overhang this third bottom. Oh, okay, that was too far. But we can rebuild. Whoa. Perfect. Fourth block. Okay, it's actually not heavy, I'm just really weak. Okay, now this is, can it go further? No, it's about, whoa. Okay, fifth block. Here we go, fifth block. Again, I am pushing this to the limit, the extreme at every step of the way. But it's rough because of course I'm doing this in real life. Now let's see if, oh, well, okay, this one needs to come in. Nice. So we have built here the beginning of a leaning tower of liar. I say beginning because this tower will have no end. You can keep doing this forever, and your tower of single blocks can reach out to the side as far as you want, but there are diminishing returns because the amount of overhang we get with each new block goes down, and it goes down by a specific amount. Now, again, I did this with blocks that aren't really perfect. They've got holes in them, they're not completely homogeneous, and I'm not that great at balancing things. But if you look at the gaps closely, you'll notice that here at the top block can overhang the second block by about 1/2 of its length. But then the second block overhangs the third by about 1/4. And then we have a 1/6, and then we have an 1/8. A half, a quarter, a 1/6, an 1/8. Next would come a 10th, a 12th, a 14th, a 16th. This is a harmonic series. The numbers, the amount of overhang becomes smaller and smaller for every new block we add. In fact, it turns out to be 1/2n, where n is the number of blocks. Here we have 4 blocks, and the overhang is 1/2n. 2 times 4 is 8, so it's 1/8. But even though the amount of overhang we can get keeps getting smaller, it never reaches 0. So these blocks can overhang as far as we want, as long as we have enough of them. I brought this concept up to Adam Savage, and in his workshop, we built a leaning tower of liar with more than 5 blocks.
Your measure, we should be able to hang out 2 full lengths of these.
Yeah,
Within 31 of these bricks.
that's right.
I'm so dubious about that. 11, 12. Okay. Do you want to work on these 12 top ones while I play around with the...
Well, yeah, the top
Yes.
ones. Okay, and this one will...
Yep. I see it. Back this way. Oh, perfect. This doesn't strike me as it's going to work. Oh! Okay, hold on. Here, can you, let's see here. Let go. Whoa! Huh. Let's see here.
Here's the one that you drew on.
Yeah, but I'm just,
Look how close.
I'm 3/4 of an inch away from 2 full. I didn't think that was possible.
So there are 4 slats that are not even above the table.
That's mind blowing. Okay, will you come protect it again?
Yes.
I want to get that last 3/4 of an inch, and I can do it. I'm pivoting on the back here. So I think this is the most we're going to get, and I'm about to mark it. Bottom one is there. Top one. Is that right?
Yeah.
Yep. We're within a half of an inch of two complete lengths of this hanging out over the edge of the table. I am freaking blown away by that.
This is a structure we see in super ancient buildings, like
Really?
before more, permanent solutions were found for stretching things up and across. This worked.
Wow. I really dig that. I'm going to get on the other side. I want to, we tried for years on Mythbusters to think about a proper way to do the straw that broke the camel's back.
Ooh, yeah.
And it strikes me as we're...
How touchy is it?
I feel
like a card placed there would collapse it.
I feel like a card place here might actually do it. Ready?
Well, yeah.
Okay, here we go.
So...
So, guys, hope you watched the video. Okay. Now, I asked you to look at this curve, right? This curve. Okay. Now, what did this resemble something that you saw in the video? Yes, they constructed something, right, using harmonic progressions. Okay, so I mentioned while the video was playing, I explicitly mentioned it. Okay, now I'm going to just show it to you again.
Hi, my name is Michael, and on this episode of Michael's Toys, we are going to be playing with blocks. I'm sure you've played with blocks before and have noticed that it's quite fun to also problem out is to be and well, stream have it keeps zero things down, and it goes down by a specific amount. Now, again, I did this with blocks that aren't really perfect. They've got completely balancing. If you top one, but then the second block by about and 8, a quarter, a sixth, and 10th, a 12th, a 14th, a 16th. This is a harmonic series. The numbers, the amount of overhang becomes smaller and smaller for every new block we add. In fact, it turns out to be 1/2.
So this is what I was talking about. You can look at this. The distance here is 1/2. Here it is 1/4. Here is 1/8. 1/16. 1/32. 1 by... Now this is like we're talking. This is, guys, this is harmonic progression. Okay, this numbers 1/2, 1/4, 1/6, 1/8, 1/10. These are harmonic progressions, because you do reciprocal of this, you will get 2, 4, 6, 8, 10. What is 2, 4, 6, 8, 10? It is arithmetic progressions, right? So, see, you can see the real life application of harmonic progressions, how numbers help people construct buildings. When they construct a building like this, they are sure this looks like a step, right? Maybe if you want to go from here to here, you can be sure that the building won't collapse. The building won't collapse because of this mathematics, guys. So this is why when you see people constructing, they are always like having rulers and measuring equipments. They are always concerned. Their concern is that the measurements are right. If the measurements are wrong, even a little bit, then you have a building which collapses. Okay. So that is why mathematics has helped. Okay, so you'll have to learn mathematics like this, where you apply mathematics in real world. Then you will never forget the concepts. And I guess that's it for this video. So these questions, I guess you know this, right? It's just for practice. Just take this out and practice. First, we do multiplication and then addition. Here, we take the power and then division. Okay, and then finally do subtraction. And here, you know what to do. Go for the brackets first, then multiplication, then division, then it is addition. Finally, subtraction, and you get the answer. Now here, first go for the brackets, and it is the inner bracket, so you have to do 16 minus 4 first, and then you do 2 square plus 2, okay, which is 6. Then solve the power, then look at this second, this bracket, okay, you get 6. Then look for this bracket, square brackets, okay, addition, and you will finally have subtraction and get the answer. And in prime check, I've told you, is 631 a prime number? Take the square root and prime numbers below 25. These are the prime numbers. Check if it is. This is where understanding divisibility rules becomes very important, because 2, 3, 5, 7, 11, 13, 17, 19, 23, all these numbers have a rule. Okay, you don't need to sit and divide everything by divide 631 by all these numbers. Okay, there are divisibility rules. Apply the rules, you will get the answer very quickly. Okay, so make sure you understand divisibility rules at least up until 25. You must know divisibility rules up until 25. Now 631 is not divisible by any of these numbers, so the listed number is a prime number. 631 is prime. Okay, and we have a prime check for a large number. So 7474581, guys, if you start taking square root for this, it will take a long time. Okay, there is another way to find if a number is prime number or not. Okay, all prime numbers compulsorily have to use the format 6n minus 1 or 6n plus 1. Now what does it mean, 6n minus 1, 6n plus 1? Okay guys, where n is a prime number. Now 6n minus 1, so 6 1 minus 1, 6 1 plus 1. Okay, now replace 1 with 2, replace 1 with 3, replace 1 with 4. Okay, if you do that, what happens? This is 5 and this is 7. You know both 5 and 7 are prime numbers. Okay, so all numbers of the format 6n minus 1 and 6n plus 1 are of importance to us. The reason is, see, if it is a prime number, it should definitely be either 6n minus 1 or 6n plus 1. Okay, where n is a natural number. So I've written that, right? Natural number, okay, starts from 1 and it moves from there, 1, 2, 3, 4. Now, so a prime number must compulsorily be 6n minus 1 or 6n plus 1. But all 6n minus 1 and 6n plus 1 are not prime numbers. Okay, so check if guys, look at this, 6 into 6 minus 1. Now this is 6n minus 1, right? What is 6 into 6 minus 1, guys? 35. Is this a prime number? No, right? So you be careful and understand, all prime numbers will be of the format 6n minus 1 and 6n plus 1, but that doesn't mean all numbers which are of the format 6n plus 1, 6n minus 1 are prime numbers. Okay, there are some numbers which are of the format 6n minus 1 and 6n plus 1 which are not prime numbers, but if it is a prime number, it surely will be of this or this format. Okay, you understand that carefully. Yeah, all numbers of the form 6n are not prime numbers. Okay, so you just have to understand that. The method can be used to identify if a number is not a prime number. This method cannot really say if a number belongs to prime category. Okay, this method can tell you if a number is not a prime number, but you cannot surely say if it is a prime number or not with this method. Okay, so we say but we can prove this using this. See, 74748 is not of the form 6n minus 1 or 6n plus 1. So surely you can say this is not a prime number. Yes, only if it was of the form 6n minus 1 or 6n plus 1, you might have a doubt that those numbers could be prime or not prime. Okay, if it is not even of the form 6n minus 1 and 6n plus 1, surely this is not a prime number. So you can answer this long question within 2 seconds. Okay, This is one more way of doing it. Okay. Anyway, I think we come to the end of the session, guys. We'll just going to give you a problem in harmonic progression. They've given you the fifth term, the seventh term. Seventh term is, they say it is 30, but you take it as 1 by 50. Okay, the fifth term, seventh term of a harmonic progression is are 30. Okay, you do 1 by 30 because 1 by a plus 4d is 30. Okay, 1 by a plus 4d is 30. What is a plus 4d? It is 1 by 30. 1 by a plus 6d is 50. So you reciprocal that, you will get this. Okay, so that is the reason why we get this. Anyway, we get a is equal to 3 by 50, d value substitute here, you will get the answer. Okay, simple mathematics. Please just go through it. If you have any doubts, we'll clarify it in the doubt clearing sessions. Okay, anyway, thank you for tuning in.